That's what they do in college, right? They just upload the lectures, all of them.
Yeah.
So then you know what people do? They don't go to class. For real.
Okay.
People are just like, don't go to class. Why?
Thank you for the idea.
All right, here we go. What happened? Do you have an idea? Shh. All right, guys, let's keep it rolling, guys. So histogram is good for large data. Number 2 is it's really easy to make. I'll show you how to do this. It's really easy to make. And number 3. And it is perfect if we give you a frequency table, and I'll explain what this is in a second. It is perfect if we give you a frequency table. A frequency table looks like this. A frequency table looks like the following. This is a frequency table. So this is, I say, AP classes and a number of people. So 0 AP classes, maybe 10 people have 0 AP classes. 1 AP class, 25 people. 2 AP classes, 8 people. 3 AP classes, 1 person. 4 AP classes, 2 people. I don't know.
It measures mode.
Right, okay, yes, this is where we're going to go next. Frequency table just tells you how many individuals are within each group. That's it. So like 10 people, 0 AP classes. 25 people, 1 AP classes. Different groups. Right.
How do we not? How could we not get confused with the stem plot, stem and leaf plot? With it? Because I mean, like, they're kind of similar, so you wouldn't like. Be able
So okay, stem and leaf plot is okay. So they look similarly in the drawing, but they tell different things. First of all, there'll be no key, and there'll be no stem unit, leaf unit. That's one. Number 2 is stem and leaf plots show, like, if there were 25 people who take 1 AP class, for a stem and leaf plot, there would be 25 ones. Here I just write there are 25 who do 1.
So it's just like a simpler version of the dot plot.
Yes.
Okay.
And it's better when there's more data, so you don't have to put all those dots up there, you just... And as Alex was saying, it's very easy to tell the mode. Easy to determine the mode, as well as the spread and the shape. Alright, so this is just kind of what it is, and now I want to show you an example and we can walk through this. So if you look on the top left side of the blue handout, you see all the different scores. So maybe these are scores on a statistics AP exam. I don't know. Let's think of it that way. These are scores on an AP statistics exam. 2 people got a 1, 5 people got a 2, 4 people got a 3, 2 people got a 4, 1 person got a 5. Now, a histogram looks like what you see here, and there are a couple very important points about the histogram. One is each of the bars, right, goes up by the number of people who are within that category. So 2 people made a 1, so the 1 bar goes up 2 spots. 5 people made a 2, so the 2 bar goes up 5 spots, etc. Now, when you make a histogram, you as the person drawing the histogram must decide how big you want those bins. Let me explain what I mean. Compare what is on your sheet to what I'm about to draw here. So look at what is on your sheet versus what I've drawn here.
The range.
Notice here on my sheet, on my histogram, I grouped everybody together who made between a 1 and a 5. So I just had one big bar up to 14. Whereas the one on your sheet has different bars for the people who made a 1 versus a 2 versus a 3 versus a 4 versus a 5. Does everybody see the difference there? So there are so both histograms represent the 14 scores. This one broke it down much more than I did. Clearly, this one is much better than this. Because with this, maybe everybody made a 5. Or maybe everybody made a 1. I have no idea. Here, at least I know. Everybody see that distinction? Victoria. Like these things, you all will draw them.
So we'll draw it like on the time of the rest of these 1 through 5 and draw it like that and give a question and
You mean one? Oh, okay. So you're saying, how do I like determine like how big this is? Is that the question? Yeah, that's a great question. So basically, there is no true formula. And there's no one way that is perfect. I think we could all agree this is not very helpful. Right? This is not helpful. Now, maybe in some cases you want to go by 2s, if the data looks like that. Maybe in some cases you want to go by 5s. If I was doing income of people in the United States, maybe I would go by $1,000 for income, because there's such a big range of incomes. We call this the bin size. We call this the bin size. And there's no right or wrong answer on the bin size. You have to determine it based on the data you are given. Alex.
So the bin size is like a miniature range?
Yes. And then the height of the bar is the number of data points within the bin. That's a really good way to think about it. Let me repeat what Alex said. A bin is like a mini sort of range, and the height of the bar, bless you, is the number of observations within the bin. Let me go Shamira and then Diana. Shamira. Definition of like what I just said? Okay. Diana, what was your question?
No, I was going to ask you, what would be the bin size of this one? That it's more
What is the bin size? Okay, so hold up. I'll take that question. So, bin size depends on data, and bin is like a mini range, and the height of each bar is the number of data points within the bin. Number of data points within the bin. Okay. Shamar, is that what you're asking? Okay. Then, do you mind repeating the question real quick for me?
I was asking since that's the bin size, there will be the bin size in the...
For this one?
Yeah, that is most.
Did somebody answer that? What is the bin size in this case?
1.
1. Right. Each time we go up by 1. So the first bin is from people who scored a 1. Second bin, people who made a 2. Third bin, people who made a 3. Fourth bin. Let me stop here and see this question, Shamara.
So the bin size is like the amount that you go with for each time?
Yes. Yes. So like yes, because if I had like the next bar would have been from scores from 6 to 10. Right? So this is 1 to 5, 6 to 10, 11 to 15, 16 to 20, blah blah blah. Now, obviously, if there was no score from 6 to 10, I don't draw a bar. Right? I mean, if there are like 0 data points, you don't need to like draw the bar. Right? Okay. Rogelio.